Okay. Is this visible?
Yes.
Okay, let's start then. Yeah, hello everyone. My name is Pavithra Kodmad, and welcome to React Meetup. I thought Kiran will have some introduction ready for this.
Yeah. this,
Yeah,
this
I don't
how.
know how online meetups go actually.
Yeah,
How they start and how they yeah switch and stuff. Um, this is my second one, I think. Yeah, so welcome to the meetup. Mine is the first talk of today. Um, Whoever's watching, it's awesome to be here. I didn't think I'd be coming to a React Bangalore meetup this year, but we have these circumstances. I hope you're all taking care of yourselves. Yeah, so my name is Pavithra Kodmad, and I am a front-end developer. I work at a company called Atlassian on a product called Jira. I've been here for around 3 years. I live in Sydney, Australia. I am working on a YouTube channel. So yeah, like, share, subscribe. Yeah, and that's my Twitter handle. If anyone was looking for my updates on what I'm working on. So today, okay, how does this work? Yeah. So today, my talk is going to be about web performance. Web performance is a niche for web developers. I'm going to be talking at it about it mostly from the viewpoint of a front-end developer. It's not a React specific talk. It's not even JavaScript specific. It's related to the topic of web performance, and it's a guide. It's a beginner's guide. So I'll start from the very basics of web performance. One thing that I won't be covering in this talk is why web performance is important. I think in 2020 we are all in agreement that web performance uh, really makes or breaks a website or web app. People expect fast web applications. Slow ones they have increased bounce rates. Slow e-commerce websites lose revenue, uh, don't get their conversions, and all of this is known. Like rage clicking is very common. It's part of the Urban Dictionary. So I guess by now we all do know that web performance is really important. So I'll just skip that part. I won't show you any like resources regarding that. Uh, Instead, my agenda for today is going to be all about why web performance is so hard. Why, even though we know that it's really important, we see more slow websites than fast websites. By default, we build slow websites. Uh, what do you measure to determine the performance of your application? uh, what tools and techniques kind of that I recommend or have used and or are industry standard. I'll talk a little bit about that. And in that section, I'll talk about what APIs you can use to have custom metrics, and I'll just touch upon some monitoring stuff, not too much. Um, yeah, so let's begin this then. So why is web performance so hard? Like, what makes, I think in my career at least, this has been the most unpredictable thing that I have worked on. It never turns out to be like as I expect. It always works differently on people's computers than it does on mine. Uh, I attribute this to like these three factors basically, that all the tools that are available for to measure web performance work after you have made the code change, right? After you've made the code change, and possibly after your customers see these new features or new code changes, is when you will truly realize that you have degraded performance or even increased performance. So this is bad. Like there's no tool that tells you before you merge your code that, hey, you're going to slow down the website. So it's very late in the life cycle for you to revert the whole feature. Instead, you'll just be left diagnosing like why something would have happened. So I feel that's kind of something that makes it really hard to have good web performance all the time and on websites. And also the next one is that there are many diverse factors that determine user experience. It can be like somebody is using an older computer, somebody is using a different browser, uh, or they have, maybe somebody has at some point of time a lot of Chrome tabs open, it's eating their memory, and that's why there's not much memory to run your website. It can be very diverse, like all the factors that determine good web performance for the user. And so on your corporate network with your laptop or computer, things may be working okay, but that's not what somebody else will see. So it's hard to test for all these cases, even after or before you commit the code. And just plain entropy is because the more features and more code that you write for your web app, the performance is not going to improve by default. It'll always degrade by default. Uh, it will trend towards getting slower than trend towards getting faster. At least that's been my experience. So unless you're on the lookout, performance will degrade. So that's why I feel that it's really hard. And like talks like mine exist, and I am able to, like, we all have to share our experience on how we've been able to improve it. So my kind of mantra for it would be that you measure performance, you need to monitor performance, and you need to cultivate a culture where everyone is measuring and monitoring. So only that kind of translates to fast websites in my experience. So about measuring. Why do we have to measure? If you have this question, at least I feel it's clear cut that it is a scientific and objective way of uh, of knowing something, right? You cannot improve something that you can't measure. So even if it is really bad, even if a user complains it's slow, if you don't have a metric that you can improve, so that gives you the feedback that your changes are making this website fast, then uh, that's not a way to work towards something. So you have to measure, but what do you measure, right? So to measure, Google usually tells us, people usually follow whatever Google puts out in this space. And the latest thing that they put out, I feel, is the most comprehensive kind of measuring guide to this. They call it Core Web Vitals. And I think it's a great like baseline to start thinking about what you want to measure on your website. Uh, this set of metrics, yeah, this is a subset of of a huge, larger set of metrics that you can measure. But I think they'll touch upon the most important points of your uh, website's performance that you should be aware about. So I'll talk a little bit more about them. Beyond this, you can of course measure custom metrics. You can measure how long that dropdown takes to open up, or how long a particular transition takes, or anything you want. So what are core web vitals? I thought I'd talk about them. They're really, really new. And I really like the concept behind them. I feel like something so comprehensive to explain what to measure did not exist before. It was there, bits and pieces, but this kind of brings everything together, and I like the direction that it's headed in. So Core Web Vitals focuses on three main aspects of web performance, on loading, on interactivity. Loading is like first load, on interactivity, and visual stability. So I like that there are three clear-cut focus towards performance, and each of these this metric has thresholds. Like there's a threshold in which your users are happy. There are threshold where up to where it's acceptable, and after that, beyond which it is really, your web performance is really bad. So that's an overview of the core vitals. It's based on, so if you go to this website and read all the stuff that they've put out on this, it's based on solid human-computer interaction research, and it's why these, and there's good reasoning behind why these thresholds exist and why they have chosen this particular metric and all of that, which makes for an interesting read, and it'll convince you that maybe you should also start thinking along these directions. So I'll break this down for you in this talk later. Yeah, and also if you follow Adio's Money, he typically tweets all about, uh, like he's in the team that's implementing all of this, I suppose. And they have like solid research that says that core web vital thresholds, if you're within that, your websites are doing better. So to break it down, let's talk about each of them and what behavior in your web app affects these numbers. So the largest contentful paint is a user-centric kind of metric that they put out as part of core web vitals. So it basically indicates to what will be the biggest piece of information on your website and how long does it take to load that biggest piece. So it's a good replacement for TTI that they're proposing, though I don't fully agree with it. But the point here, I think, is that TTI, you can lie on TTI. TTI, time to interactive, you can decide wherever you want that the page is interactive and send this metric. But largest contentful paint kind of forces you to focus on the biggest piece of information that you're displaying to a user. It may be media or it may be text. So it focuses on that, and I like that. Uh, yeah, I like that you have to wait until the biggest thing on your website waits until you declare that the user, it's useful to the user. Earlier, Google used to propose first byte, time to first byte, uh, which I felt was pretty useless because it's not useful for the user to look at the first byte, right? They have to wait until everything's entered on the page and they are able to interact with it. So this is a good, this is a step in the right direction, and it gives you achievable threshold. So it's good if the largest piece of content on your page loads within 2.5 seconds, which is doable, right? Many websites can reach there, and it keeps your users happy. That's proven. And beyond 4 seconds, of course, the website is really, really slow. So what affects LCP? So LCP can be affected by a slow server response. So if the request that you send back to the server, it comes back really slow, then the largest piece, the data for the largest piece cannot be retrieved soon, and so it will affect the LCP. If your critical JavaScript is not optimized, if there's a lot of bulk in that code, if that bundle is too huge, that'll affect LCP. And inefficient rendering, if it takes a lot of renders to show things on your page, if there are unnecessary re-renders or large components are re-rendering, that's bad. That affects this metric. And large resources like images, videos, and things like that, of course, will affect it. So if you see that your LCP is really low, then it's time to dig down into these factors and determine which kind of slowness you're experiencing. The next one is first input delay. So I don't fully agree with this metrics, with this metric. But I feel it is useful to start thinking about interactivity on your web app. So it's not just the first load that's important. So once a user starts clicking on things and using your web app, it should be very interactive, and there should be a way to check that. So here they propose that you are able to click and the website interacts in 100 milliseconds. So once it's ready, once the largest content has loaded and user clicks on it, it should come back within 100 milliseconds for a good experience. This accounts for SSR freezes, I feel, so that's a good point of this. But yeah, it's a good place to start thinking about interactive performance of your website. So what affects it? Third-party code that's still loading, after everything else on your page is loaded, if that's blocking the thread, if your bundles again are really large, and if you are using server-side rendering and hydration doesn't happen, so if things frozen, you click on things, nothing happens. This, I think, will measure all of that. The last one that they ask you to measure is cumulative layout shift. Again, I like that this refers to perceived performance, like how noisy the web page is to the user, right? So good one is, so you kind of measure this by how much, how large of an element on the page shifted how far away. So there's a formula for that. There's a method in Web Vitals GitHub repo that you can use to do this. I myself have not tried this, but I'm going to start implementing this as we at work also start looking more at perceived performance. So what affects this is you shouldn't insert content above or above things, especially if you have already rendered a layout. Don't insert things in between after the show skeletons and things like that. Use CSS transforms, don't change widths and heights a lot, and don't change asset sizes. Like don't images should not like change sizes while it's loading, while the page is loading. It should have fixed sizes. These things will determine the cumulative layout shift, and anything else that's noisy to the user will also contribute to this. So these metrics are all well and good. How will you measure them, right? So right now, the core Web Vitals are only available through a Chrome extension. I tried this out, and it's pretty nifty to see. Open up any website and see what these vital numbers are. Many people suffer from bad cumulative layout shifts, and it shows bad LCP too, which is pretty cool. This will also transfer to Lighthouse. I think versions 8. I don't know, the next one at least. It's not there right now. I tried it on Canary and on Novel Chrome. But Lighthouse Audit is a good place. Lighthouse Audit currently also shows a lot of metrics, so it's a good place for people to start. And web page test. So Lighthouse Audit itself, it looks something like this. You open up your page, you go to it's a tab on Google Chrome that's integrated within every Chrome instance, and you run an audit on the page. You can check whether it's mobile or desktop, and you can also run other audits, but here performance one is relevant. And then it gives you a score, and then it shows you the breakdown of different of other metrics that also you can read about in Web Vitals. It also shows you how the page kind of loaded, when content started appearing. So that visual kind of helps seeing how many frames came up with nothing in them. And it gives you a set of reasons which you can act upon. I think it's a great place for people to begin auditing their websites. If you have a blog, if you have a marketing website and things like that, use Lighthouse Audit on them and try to improve that score as much as possible. Next is web page test. Web page test is a place where you go and you can choose which device, which location to run your test web page in. And here I'm running my blog. Um, yeah, it's decent at what it does. You have to kind of retry multiple times for it to work. But I think it gives valuable information. It also gives you a profile that you can open on your Chrome performance this thing tab, and kind of look at how it performed in these different conditions. Other stuff you can you can try this out for your blog and stuff as the next step after Lighthouse Audit. So other stuff you can measure is uh, custom metrics. So now you can put things around, put timers around every piece of code that you want to like measure the timing for users. And you can use user timing, resource timing, navigation timing APIs that will do this for you. So everything comes under window.performance object. So user timings API refers to mark, measure, and to get these entries. Marking, this is the code that you would typically write. So before you do a task, uh, you can start a mark, you can have an end mark, and you can kind of this will be timestamps that it will return, and you can store them, and like you can see them in your console and see how things work. You can go here to see more about marks and what other kinds are there. So to measure is to like see the difference between marks and yeah, and send other details. Even you can send like a feature toggle that's controlling a feature, and see when it's toggled off what kind of measurements you get, and it's toggled on what kind of measurements you get. So this can be useful. Other API that I can quickly say that are useful are resource timing API. This gives you timings of all the resources that you loaded, maybe JavaScript files or APIs or things like that. And it just the browser just records them for you. You don't have to do much, but just pull out the entries from here. Navigation gives you like when pages changes, when page transitions happen, it gives you numbers about that. You should read more about this and see if it is useful. Maybe it's not, maybe it is. You can use them accordingly. It's available. So if you are a much more serious website, you have customers, your B2B customers, and you are more serious about performance, then it's best to have it, and you work in a larger team, right? It's best to have a lab kind of setting. So if you do branch builds with Netlify or something like that, you can have any of these tools do the web page test or Lighthouse audit for every branch build that you make. That should give you like early indication of how your new features or new PRs are behaving in the wild. This is a great resource that Sean Wang has written. You can check that out. The last kind of thing, like this is like heavy performance monitoring stuff for large scale apps or apps that are really slow, and you can't find out why they are slow, and they have tons of users, features, and a lot of complexity around them. I feel at this point you have to do real user monitoring. You have to know what are the range of experiences that your users are experiencing. So real user monitoring consists of using various set of tools for you to actually get all the measurements that I talked about before for all of your real users, anonymized data, and then aggregate them to see what is the general range of performance of your web app. So for somebody with a super fast computer, super fast network, what kind of numbers will they see for TTI or LCP? And a user on an old desktop with the IE browser or whatever, what they will see. So you will have to distribute the data and see when you use real user monitoring. So real user monitoring is called RUM, and it needs, I feel like, three characteristics. It's a system that you build, and it's not a beginner's concern. If you're doing real user monitoring, you probably need an observability team in your company who does this. At least that's what I have in my office. You should be able to query all the data that's collected. You should be able to slice and dice and have different data in them. You should be able to create some kind of trend visualization, like what was this number like last week, have we improved it this week, and so on. You should be able to add alerting also. So when something happens that breaks this barrier, breaks this threshold, your team gets alerted so that they are so you can create a ticket and then follow it up and see why this happened and investigate why it happened. So if you're doing all of this, then you are basically a part of a performance culture. A performance culture you can define when you as a team on working on a product use both offensive and defensive approaches to make your web performance better and maintain it to be good. So offensive approaches can include things like profiling your app as part of a PR merge or something like that with your teammates. When you're before approving the PR, you both profile your application, see if something's wrong. A shameless plug is I made a video on this. I couldn't find any other resources, so I made one where I explain how to profile your application using Google Chrome Profiler. It's pretty detailed. That gives you a lot of information and tells you how the new stuff that you wrote performs. You can get some idea of how things are. When you write app code, you look at memoizing sensitive part of the sections. You make up API calls really early. You see how many times re-render happens. You're using your React profiler or something like that, and you're always fine-tuning the critical path. You're deferring stuff that doesn't need to happen immediately, and you're trying to give your user the best experience. Other defensive techniques, I mean that you have to have a culture where you talk about performance, and if an alert happens, if some kind of regression happens, say for your page was loading under 4 seconds and now it's 4.5 seconds, you have to follow up and see what changes made this happen, and try to effectively bring it down. One example of this on my team, at least, we have a technical operations kind of meeting every week, not every 2 weeks, and we talk about performance. We talk about why the number is at where it is, whether it's reducing, whether it's increasing, and so on. Even if you're a one-person team, you can like take apart some time and think about performance. Is on a lower scale is also enough to build a performance culture within yourself. I have not seen any app working fast without adopting any of these techniques. Even when you adopt these techniques, it's still quite hard as your team size increases and things like that. So I have seen good results only when you have a good performance culture. So I feel it's worth it, worth doing. And yeah, that's a takeaway from this talk for you, that if you want to have good web performance, then you have to care a lot about it, and that'll make it worth it. So yeah, that's my talk for today. Thanks for listening. I just went on with my talk, and I don't know if people have been hearing it or not. So I'm open to any questions if that works here. Yeah, that's all I had to say about web performance for beginners. I hope that was useful to you.
Yeah. Thanks, Pavithra. It's really informative. I think we'll have some time for questions.
Okay.
So people who are on Zoom, if you want to ask some questions, you can unmute and ask questions. People who are on YouTube stream, you can type the questions so that I can relay that question to Pavithra.
Ooh.
Yeah, good evening, ma'am.
Hey,
Hello.
hello.
Yeah, good evening, ma'am. Yeah, the session was really interactive. I work as a web developer in a startup. So I had a query that the things you told that was exactly correct, that whatever measures I take, it doesn't work out perfectly or anything. But you told how to measure the metrics. Okay. But how to optimize these things? Could you give a little bit feedback how to get the solution to increase the performance? We are aware about these things, that how to measure and all these things, but how to get the optimum solution to get the performance increase, that's the thing I want to know.
So why I didn't speak much about that, because it is very custom to your application. You have written that application code from start to beginning. You have made various choices, right? Maybe you are using Webpack, maybe you are using Parcel, maybe you are using React, maybe you're using Vue. Maybe for you, your web application consists of large tables that need to be scrolled, or showing large lists, or maybe somebody's is more interactive heavy, maybe they have charts more. So I feel that web applications vary so much in form and function, and the tech stack that they're built on, even the backend matters, right? Like that, your server response also should be optimized for this. For me, I work on a single page application that's built in React. We use Webpack for bundling it, and we use microservices to make our API calls. So in this setup, at least, I have found that for performance optimizations that we have been working on, is to like, first step at least is to fine tune your critical path really well. Like it's very it would be good if you knew what exactly is the code path that takes the user to show a useful page, to see a useful page. What is that code path? Defining that code path is, I think, the hardest thing. And it's also like, as new people add code to it, if they have to know whether they're affecting that critical path or not. And there is no tool that tells you that this piece of code is on the critical path. So it's up to you to know your application so deeply and know that path for this thing. So for us, it is usually like there is SSR that comes in, then there is the SPA shell that loads up, and then there is API calls that need to be made to show that particular route, and then the route rendering of the route itself. So we are trying to optimize on these three pillars. We are trying to make our SSR faster. We are trying to stream the HTML onto the page as soon as possible. And we are trying to even like add a small script tag at the top, which will make all the API calls as early as possible, so that as soon as the JavaScript is evaluated, the data is present for you to render, because we felt that was also a bottleneck. And we are next trying to, so there is also like when you load JavaScript onto your page, even if it's asynchronously loaded, you have to determine the order. If you read the new blog post by Facebook on how they optimized for Facebook, they have this import mechanism where they what they do is they have different categories of imports, like what import is required for the critical path and what import can be done after the TTI is sent. So that's really new stuff. That's something also we are also working on. If you go to Atlassian Labs, you will see a library, but it's not ready yet. We also have an internal tool where we have started to measure the number of re-renders that happen on every. You can get that information from the profiler, but profiler tends to be like too slow and too big. So our tool kind of pulls that out and gives out components with the most number of re-renders in sorted form. So we've been going through those and trying to optimize. So yeah, it's been like attacking it from many fronts. And it's also important to be defensive, because so now we have a system where when you toggle a feature flag, we run the lab condition tests on it on a 50% of that feature flag. Yeah, and that was also like surface a lot of issues before it goes to production. So it's been easy. So you can just contact that team and tell. But again, you have to like police also. So because otherwise the performance tends to go down only, is what I've experienced. So doing all of these things is a lot of effort, and you have to put priority to that also, right? I mean, there's feature development and then there is focusing on performance. So yeah, it's depending on how important it is to you and how well you know your code base. Yeah, the more marks you put and the more you measure, it's better. So right now we have a measure for every point, like when does the SPA finish, when does the rendering start, when does the API call start, when does that come back. So we have that breakdown. So whenever we make any code changes, which part of that breakdown changes is a good place to know. So I'm just like, this is not industry standard, this is what has worked for us right now. So maybe that will help you.
Okay. Fine,
Pavithra, we have one couple of questions on YouTube stream. So one question is, how to reduce the impact of third-party scripts, like Google Analytics or Google Tag Manager, something like that. How do we reduce the impact of third-party scripts? That's the question.
So this is something. I think like not put that script tag before all of the things. I guess I don't. If I need any third-party scripts, we have a way of like deferring them after. So yeah. In that context of a small page or a blog page or marketing page where you just add Google Analytics on the top, maybe use JavaScript. Yeah, I don't have a proper solution for that, unfortunately. Maybe like you could Google and find out, I guess. Yeah. Or I'll let you know once I find out. It's not been a concern of mine usually. So that's what somebody tweeted at me, that third party, their Twitter logo on that. So the Twitter like and share button that she had included kind of was slowing down her website or showing bad numbers on Lighthouse. And then she said she corrected it. So I tweeted back at her asking what she did to correct it, but she never got back to me. Yeah, I'm also curious to know how to do this. Maybe because of this question, I'll try to find out.
Yeah. So one more question Chirag Verma is asking is how to automate the performance checks from multiple locations.
So this is what, okay, so this depends on the scale that you're operating at, right? If you just want web page tests to run, apparently you can do that. I showed you a slide with all the different tools. I think there are paid tools also in that list that will let you, if you provide them with that, with the URL where your app is deployed, they will hit it from different locations, giving you the same numbers like web page test and Lighthouse. Yeah, I'll publish my slides today, and
Yes.
you can find the link in that.
Yes. Yeah. So anyone else have questions? Maybe who are on the Zoom?
Hello.
Hey.
Yeah. Hi.
Did somebody speak?
Yeah. So yeah, myself, Harpreet. I just want to understand, like, do we have any sort of tool that we can integrate with the CICD process so that we can get an alert on like LCP values and all?
Yeah, this is what, right? This is what I said in the beginning, that it is hard to do. So see, you would have to build the branch there and then hit it with all of these. No, we have not been able to get it into a CI/CD process like before you merge stuff. So what right now the process we have is after you merge, then we run checks on this code base, and we run them on all the locations where we deploy, on machines reserved in all the locations where we deploy. So we get data from all the locations. So we just have to like soak it for a half a day or something, and it tells us. So it's before it goes on to production. So yeah, we get that little early hint on whether it's affected things or not. If there is a tool that will help you do it before you can merge your code, then things would be really easy, right? I would write a test and then I would just see whether like I improved or decreased performance or not.
So it's a kind of A/B testing kind of we are doing right now.
Yeah, that's what at least we are following right now.
So New Relic tool has that, I think so, but there's a paid one. So I haven't
yeah.
to like look into it, but I have thought
yeah,
of
that's
like,
what it's.
Yeah.
Yeah, exactly. So if it depends on what scale you're operating. If it's that important to you, you will have to like get New Relic as a company and then use that to dice and slice this data.
Okay, sure. Thank you.
So we have one more question here. Someone is asking on the YouTube stream, like we generally have these bundle size checks, right? I think Siddharth also wrote one script, one tool for that. The person is asking like they have a big team and they set a limit, but when multiple teams are working, they are crossing the limit frequently. So how do we manage this,
So we kind of have now. So bundle size, of course, it'll keep increasing. So we do encourage like people to make async bundles as where and when possible. So we have a bundle size check based on Webpack gives you bundle size information on every build, right? So what we do right now is every time a master build runs, the main build runs, it kind of stores the current bundle sizes. Then we have a list of all the so we have this default delta of bundle sizes increase that's acceptable. And then a kind of bash script runs after every build on a branch where it compares the bundle sizes on the branch to the bundle sizes on master and shows you this difference. And if the difference is higher than this delta, then it fails the build for us right now. So that's how we are keeping a check on bundle size. So then if you have to pass the build, you have to increase this delta manually. And so the stakeholders can like look at why this is happening more detailedly. So at least that's what we are following. It kind of works, but people, yeah, there were no good tools like to get into the bundle size and see which part of the bundle has increased. And this may not the bundle size increase may not be because of your change also, right? Like you might have just imported, or you might have updated some package, and it kind of Webpack distributes them weirdly based on what kind of configuration you give it if you're using Webpack. So yeah, bundle size is a tricky thing. It does tend to go up all the time. We try to police it as much as possible. Um, yeah, it's again like you have to spend the time to investigate why the bundle size is increased. Is it valid for your change? Is it acceptable? You have discussed with your teammates and then push it in. If you have that culture, well and good. Yeah.
Yeah.
The tools exist though for bundle size measuring before you merge your code.
Yeah. I think one more question is, for beginners or students, if they want to start thinking in terms of web performance, where can they, what is the good starting point for them?
So yeah, so for beginners, you can start looking at how websites are performing by just opening Lighthouse on Google Chrome. Just see the values. If you have a personal website, just try to make it as performant as you can. Also, you can read through the Web Vitals link that I'll post in my slide. It has really good information, and like there's a lot of links to like research and papers that people have done, investigating how users respond to performance and what kind of things are should be measured or you have to keep in mind and things. So that'll give you like good direction to think in, I think, if you're looking for a resource to read and understand. And yeah, I make videos on web performance, so you can look at that. I'll make more. And you can also look at Google developer videos. The Google channel has a lot of videos, and it has a whole section on performance, which is also good. And anything that Adi Osmani puts out, all those things you can read. Yeah, just follow Adi Osmani on Twitter. He puts up a lot of performance resources from time to time.
Yeah. Yeah, I think that's all the questions we have.
Cool. Yeah, we also use Webpack Bundle Analyzer, but again, it has difficulty. I'll just like, there was a comment on YouTube.
Okay.
That has a little bit difficulty in like comparing between main branch and the developer branch. So that's why we had to build our own thing for that. Cool.